Hello students, I welcome all of you. We have already continued fourth lesson, effects of electric current. Today we discuss the topic magnetic effect of electric current and also right hand thumb rule. So in the last lesson we have studied how the effect, thermal effect of a electric current. That means thermal means the heating effect of electric current. We have already seen in the last lesson, and according to this, how the heating effect can utilize to our daily appliances, electrical gadgets in our home. So we, without wasting our time, we have to study the magnetic effect of electric current. Due to the electric current, there is a magnetism. Magnetic phenomena is also related with the electric current, with the electricity. They have to this thing we have to study in today's lecture. Here I just draw a diagram where is cell is there. Here is a positive terminal. Here is a negative terminal. Keys, plug key is there to close the circuit, whether it is to close or to open the circuit. And A and B is a straight conductor, thicker conductor we have to use, and here we have keeping a magnetic needle is there. So before closing the plug key, what we have to see, we have to observe the direction of the magnetic needle, in which direction it has been stable. After that we have to insert a plug key, and after inserting a key inside it, there is a circulating current from positive terminal to negative terminal goes on. Okay, so electric current is flows in this direction from A to B in such like that, and electric circuit is completed, so that electrons are flowing in this way, circulating in this way. But at the same time we can observe that the magnetic needle which is kept near the wire, that is a conductor AB, near conductor AB, there is some deflection. We can see easily the deflection in magnetic needle SN. Here is a deflection in such like that. The deflection is such like that. So there is slight deviation is there. Okay, this deviation we have to see the conclusion afterwards. So what happens there? But it happens when the plug key is on. Okay, plug key is on. That means the electric current is flowing in the circuit. At the same time, we can see there is a deflection in the magnetic needle. If we open the key, if we remove the key, what you have to see, this magnetic needle once again regain its original position. Its magnetic needle is regains its original position, so that we can there is a conclusion from that activity. We can conclude that there should be some relation between the electric current flowing in the electric circuit and there is a deflection in the magnetic needle. Okay, so we have to repeat this experiment by interchanging the polarity. What you have to do, we have to interchange it. Here is a positive terminal, here is negative terminal, and after it we have to insert the key in the plug key, and after that we can see the deflection found in the magnetic needle. So there, when the current is flowing in this direction such like that, actually it is reverse. It is actually opposite direction to that of the first one. Okay, the current flowing from B to A. When we have to take a positive terminal here and negative terminal there by interchanging its polarity. In the second case, we have to interchange its polarity, and afterwards we can realize that the current is flowing from B to N, at that time we can find that instead of deflection such like that, this deflection is from this direction to this direction. Okay, first one is in the upward direction, the second one is in downward direction. So in this way there is actually opposite direction. The deflection which is found in the magnetic needle is opposite to that of a first one. Why it is opposite? Because the direction of current, first one is from A to B and in the second case from B to A. So that we can easily observe those things, that there are some relation between the electric current, the relation between electric current and magnetic field. So electric current and magnetic field, there are some sort of a correlation is there, and this type of correlation is first found by the scientist. His name is, we have given in our book, that is Hans Christian Ørsted. He does, at that time he done this activity, and he taking all the components which is we have connected here. At the same time he became realized that there is a deflection in the magnetic needle when current is passing through the circuit or a conductor. When current is passing through the conductor, there is some sort of a magnetic field is created near its carrier, that means the conductor. Okay, so in our book we can easily see that in Hans Christian Ørsted, the person which can found this phenomenon when the electric current is flowing in the circuit, that means in the conductor, there should be we can easily experience some sort of a magnetic field near its vicinity. Okay, the surrounding portion of the conductor, we can experience a magnetic field is there, and it can be analyzed, it can be detected by using a magnetic needle. If we keep a magnetic needle near the electric conductor which having passing the electric current, they have been experienced. That means this magnetic needle can be experienced the deflection. When deflection we can see the deflection in the magnetic needle if the magnetic needle is kept in such a position, such a surrounding, that there should be a magnetic field is there. If there is magnetic field, we can see the deflection of the magnetic needle. If there is no magnetic field, then we can say that the magnetic needle is stable at north-south direction, so that we can easily find out the vicinity of a magnetic field near a electric current. That means the conductor which having carrying a electric current. Okay, so first experiment is I have already seen. So in the next experiment, the same thing on the page number 52, we can see here is a variable resistance, that is rheostat is there, then ammeter is there. We can find out so how much amount of current is there. After that a cell is there, and we have to insert cardboard. What you have to do? Here is a here is a copper wire. Here is a copper wire that is a conductor, and which can insert it through a cardboard. Okay, we have to insert this cable, and that's this copper metal wire inside a cardboard, and after once we have to start this experiment. So here is a positive terminal, here is a negative terminal. And another thing they have given here is a key. They have been provided a key is there. Key is a button which can switch on and switch off the electric circuit. Here is R. Here is R. And his R is a variable resistance. That is variable resistance. The resistance can be adjusted by using this component. This component is an ammeter which can measure the electric current flowing in the circuit, which is connected in the series, and the cell can carry the electric charge from one terminal to the another terminal via these components. Okay, so what you have to do? We have to insert a key, switch on the circuit. Circuit is completed and the electric current is flowing from a positive terminal to a negative terminal. At that time, what you have to do? We can see some sort of current is there. On an ammeter, we can measure the electric current. We can easily observe how much amount of current is flowing in the circuit. The resistor is devised such that we have to adjust the electric current. Okay. Rheostat is the device which can control the magnitude of electric current. So we have to utilize this. Okay. And key is the device which can functioning the close and open the electric circuit. Okay. So what you have to do? We have to keep magnetic needle. They shown in our book. They have already shown in our book that there is a magnetic needle we have to keep at different points. Here we have to keep magnetic needle. Here we have to keep a magnetic needle. Here we have to keep magnetic needle, and we can find out in which direction the magnetic needle is stable. Okay, static. It remains static. The magnetic, these two terminals, N and S terminals, remains stable. So we have to identify those things, whether in which direction they have been stable at different points. Here is cardboard is there. So inside the cardboard we have to insert this, penetrate this copper wire or a conductor wire through it, and after that this is it remains a horizontal. Okay, this cardboard remains a horizontal, and so that we have to keep a magnetic needle over it and check in which direction its north and south pole arrows remains stable. Okay, so we have to do this procedure number of times at a different points. You have to check whether in which direction it remains stable. So another part of this experiment is that instead of a magnetic needle, what you have to do? We have to take iron filings. They have taken iron filings there, and we have to iron filings we have to surround it. We have to surround it over the cardboard. Okay, and after when the switch on is there, when a plug is inserted in it, and when electric current is flowing in the circuit, we can easily see the iron filings are aligned. They are aligned in a different concentric circles. The magnetic filings are aligned in a different concentric circles. Why it happens? So these things we have to study. So we can easily see that we can easily understand that when electric circuit is completed, electric current is flowing from positive terminal to negative terminal, and via these 2 points A and B, in which we have cardboard is so adjusted that it is horizontal. It is horizontal to the cable or a conductor AB, and we have to surround it. Iron of filings is there, and they are, when electric current is on, that is electric current is flowing in the circuit, we can easily see that these are aligned. The iron of filings are aligned in a circles. One circle, two, second circle, third circle, having a same center. This one is the center, and these are the different circles of a different radius are there, and these lines, these circular lines shows these are where the iron of filings are aligned, that means situated there, and these lines is nothing but these are the magnetic lines. This shows these are the concentric circle, shows these are the magnetic lines. Okay, and in its vicinity we can easily see there is existence of iron of filings which are aligned in a circular manner around it. So in this way we can easily find that there is some correlation between the electric current and a magnetic field. Okay, when electric current is flowing in the conductor, it is surrounded by a magnetic field. Okay, when electric current is flowing in the conductor, there should be, we can observe, we can experience a magnetic field around it, and this can be discovered, or this can be easily experienced by the right hand thumb rule. We have shown on the page number 53 right hand thumb rule. So what is the statement of a right hand thumb rule, and what they told us, what is the principle behind it? We have to see. Here is the right hand, here is our right hand. Okay, thumb is there, and we have to hold a conductor. This is conductor, this is the right hand. Okay, this is thumb, right hand conductor, thumb. Okay, this is remaining curved fingers. Okay, hold a conductor in your right hand in such like that the thumb points the direction of electric current. It is the direction of electric current. Okay, hold a conductor in your right hand. Hold it in your right hand. If this is a conductor, we have to hold in your right hand. If thumb shows the direction of electric current, in such that we have to hold an electric conductor in such like that the direction of electric current shows, it point towards thumb shows, or a thumb indicates the direction of electric current. Then the curled finger, which is around electric conductor, shows the direction of a magnetic field. They have been stated this law. Imagine that you have held the conductor in your right hand. Imagine you have to hold a conductor in your right hand. Then in such a way that thumb points in the direction of electric current. In such a way that we have to hold a conductor in such a way that the thumb points toward the direction of current, then the remaining finger, that is curled finger around the conductor, shows the direction of a magnetic field. The remaining curled finger shows the direction of a magnetic field. That is the direction of a magnetic, such like that. Okay, the direction of magnetic field in such like that, and the direction of electric current is in the direction of a thumb. So in this way, right hand thumb rule, and it shows the direction of electric current and magnetic field. These are the mutually perpendicular to each other. The direction of a magnetic field and direction of a current and direction of a magnetic field are perpendicular to each other. So we have to stop here, and the remaining part of this thing, that is magnetic field produced by the current through the circular loop of a conducting wire, we'll discuss in tomorrow's lecture.